Hello, ladies and gentlemen. We're going to do a little absolute values with inequalities, which kind of combines solving inequalities with compound inequalities and graphing them. So it's kind of everything. Let's talk about just some basic conceptual ideas here. The first thing, what's this thing's problem? Get out of here. Go away. Okay. The first thing you need to do is kind of understand what's going to happen here. We have the absolute value of some number is less than 5. So what I'm going to do is I'm going to kind of think what numbers have an absolute value of 5. What numbers are 5 units from 0? So if you started at 0 and measured 5 units to the right, you would be at positive 5. If you started at 0 and measured 5 units to the left, you would be at negative 5. Now if you plug 5 in, the absolute value of 5 is 5. And since 5 is not less than 5, it's equal to 5. The way we indicate that it's a border is we put an open circle here. And it's the same thing over here. The absolute value of negative 5, if you plug negative 5 in, is 5, and 5 is still not less than 5. So those are open circles. Those are the endpoints. Now what we have to do is decide where are the numbers that have an absolute value less than 5. Do 0, 1, 2, and 3, and negative 1, negative 2, negative 3, negative 4. Do those numbers have an absolute value less than 5? Or do 6, 7, 8, 9, 10, negative 6, negative 7. So should I basically going out or in? In this problem, the numbers that have an absolute value less than 5 are in the middle. So that's the numbers between negative 5 and positive 5. If you pick a number in here, it should make a true statement. Like I'm just going to pick 2. If I plug in that 2, the absolute value of 2, and 2 is less than 5. If I did the same thing with negative 3, you would have negative 3. The absolute value of negative 3 is positive 3, which is less than 5. So you can kind of check to make sure you did it right. But those are, that we will call that an and inequality. And the way I know it's an and inequality is because the absolute value is less than something. So we say the absolute value is less than something. That's an and inequality. You're going to shade towards each other. The other option we have is when it's the absolute value is greater than or equal to 3. So we're going to do the same thing. We're going to say, okay, the numbers that are 3 units from 0 are positive 3 and negative 3. And since those points actually make true statements, what I mean is when you plug in negative 3, the absolute value of that is 3, and 3 is greater than or equal to 3. So it does work. But we want the numbers that have an absolute value bigger than 3. So if you try like 1, well, 1 has an absolute value of 1. That's not bigger than 3. What about out here? Like 4, 5, 6, 7. If you plug in 7, 7 has an absolute value that's greater than 3. So we want to shade towards that. We want to shade out that way. Or if you pick out here, negative 4, negative 5, negative 6. Those numbers are also more than 3 units from 0. So those numbers also work. And you're going to shade out this way. So this would be called an or inequality because it's either less than negative 3 or greater than 3. If it's an absolute value greater than something, then it's called an or inequality. They shade away from each other. The only thing I haven't done is write these as inequalities. This one would be between, that's not going to work. Oh no, I'm making it worse. Get out of here. So the minimum here is negative 5. So we would say negative 5 is less than x is less than positive 5. This is a compound inequality. That's something we've been doing a lot lately. The other option here is if you write this as an inequality, you would say x is less than or equal to negative 3. Or if you write that as an inequality, it would be x is greater than or equal to positive 3. So that's kind of just the basic idea. We haven't had to solve anything yet, but that's where it gets a little trickier. So let's try another one. So the first thing we're going to do for this problem is we're going to decide when the absolute value equals 5. We're just going to ignore this and say, when is the absolute value of this number 5? And I like to draw a little helper number line. So if this helps you, then do it. But I'm very visual. So I want to figure out when the absolute value is 5, and that's 5 and negative 5. We just talked about that. And since it's a greater than and not a greater than or equal to, these are going to be open circles. And then last thing is, since it's an absolute value is greater than, we want the numbers that have absolute values bigger than 5. And when it's an absolute value greater than, then that's an or inequality. So, or inequalities are when you shade away. So I'm going to go to the right or to the left. I know it's going to kind of look like this, but the difference in this problem is it's not just x on the inside, it's x minus 2. So what we have to do is take this number line and convert it to an inequality. That would look something like x is less than negative 5. That's x is less than negative 5. But it's not x, so I should probably just write it as x minus 2 is less than negative 5. Since it's x minus 2, that's what's going to go here. But I want to know the numbers that are less than negative 5. So these are the numbers less than negative 5. Or greater than positive 5. To the right of 5 would be greater than 5. And again, you just take the x minus 2 and bring it down. These are one-step equations, so to solve those, that's very easy. You have x is less than negative 3, or when you add 2, you have x is greater than 7. So x is less than negative 3 or greater than 7. Now all we have to do is draw that on the number line. So negative 3, I'm going to do this in a different color. Let's do negative 3, positive 7. They're both open circles because they're not equal to. And less than negative 3, we're going to shade to the left, and greater than 7, we're going to shade to the right. So hopefully you can see when you set up this little helper number line, it should look just like our answer. The only difference is since we have this x minus 2, it's moved the numbers to the right 2. Instead of negative 5, it's negative 3. Instead of 5, it's 7. Try another one. So I'm going to write a helper triangle, or a helper, not triangle, but number line. That's so frustrating. Okay. So we'll put the numbers that have an absolute value in this problem of 9, which would be negative 9 and positive 9. This is a greater than or equal to. So when it's equal to, we use closed circles. And again, since it's a greater than, we go back. When it's a greater than, that's an or inequality. So that means I know it's going to look something like this. It's going to shade away. Now what I want to do is I want to write this as an inequality, or to describe what that's saying. I want all the numbers that are smaller than negative 9 to the left of negative 9. So that would be less than or equal to negative 9. Or I want all the numbers that are greater than 9. So that would be greater than or equal to positive 9. Then you just put whatever's on the inside right there. 2x plus 1, 2x plus 1. You're going to solve both of these inequalities. And to do that, we're going to subtract 1. It's a two-step equation. Negative 9 and negative 1 make negative 10. Then we're going to divide by 2. So x is less than or equal to negative 10 divided by positive 2 is negative 5. Similarly, it's the same two steps. You're going to subtract 1. Only this time it's 9 minus 1 is 8. And then you're going to divide by 2. So x is greater than or equal to 8 divided by 2 is 4. So x is less than or equal to negative 5, or x is greater than or equal to 4. To draw that on the number line, I'm going to say negative 5, positive 4. They're both still closed circles. And the numbers less than negative 5 are to the left. The numbers greater than positive 4 are to the right. So that is our or inequality, and that's our answer. Couple more. What happened? Is this again 3? Okay. This one's a little trickier because here the absolute value is not by itself yet. So to do this one, you need to first get rid of that times 3. And the way you do get rid of the times 3 is you divide both sides by 3. So now we have the absolute value of 2x plus 3 is less than or equal to 6. Now that the absolute value is by itself, I can start to think about what I've got here. You know what? I'm just going to take this guy. So give me another one. There we go. So let's think about the numbers that have an absolute value of 6. Because this is saying the absolute value of something is 6. That would be negative 6 and positive 6. This is a less than or equal to, so these are going to be closed circles. And since it's a less than, when we go back a few slides, remember when it's a less than, then this is an and inequality, and inequalities shade towards each other. So when I go back now, I'm going to think, okay, this is an and inequality. I want all the numbers that have an absolute value less than 6. That means they're between negative 6 and positive 6. Now to describe that, to say to the right of negative 6, you will say greater than or equal to negative 6. To say the left of 6, less than or equal to positive 6. Then you take whatever's on the inside, 2x plus 3 and 2x plus 3. Now we just have to solve these two equations. So we're going to, I'm going to need more space. Let's just do it over here. So you're going to do the same thing for both of them. It's a two-step equation. You're going to first undo the addition by subtracting. Negative 6 and negative 3 make negative 9. And when you divide, you get x is greater than or equal to negative 4.5. Same two steps over here. Subtract 3. 2x is less than or equal to 6 minus 3 is 3. Then divide by 2. X is less than or equal to 3 halves. this is an and inequality. So if you want, you can condense these into one inequality. You could say that the minimum, which is negative 4.5, less than or equal to x, is less than or equal to the maximum of 3 halves. Either of these are correct. Both of those say the same thing, and they're both fine. Now I just have to graph it. So to graph it, I'm going to put dots at negative 4.5, and I'm going to put dots at 3 halves, which is 1.5 if you want it as a decimal. And it's going to look just like this. So close circle, shade the middle. And that's our answer. Let's do one more together. I'll let you guys try the practice problems. So we need to isolate the absolute value. To isolate the absolute value, you're going to first subtract 3. Now we have the absolute value of x minus 8 is greater than negative 4 and negative 3 make negative 7. Now, it's real easy to be kind of on a roll. I'm going to do this. It's going to be great. But you got to be really careful. You have an absolute value. This is a positive number. Is a positive number ever going to be greater than a negative number? It's always going to be greater than a negative number. So let's kind of maybe work it out and see what I mean. But this is going to be all real numbers. This is going to work for every number you plug in. This is a tricky one. So the numbers that have an absolute value of negative 7 are, actually there are no numbers that have an absolute value of negative 7. It doesn't matter. This is going to be positive. Positive is always greater than negative 7. So this is the whole number line. This is a tricky one. The whole number line means I need to shade the whole thing. It's going to look like this. Every number you can think of is going to work, because a positive number will always be greater than a negative number. So the way we'd say that would be, I guess you could say negative infinity. Oops. You know what? Just say infinitely many solutions. There's other notations we could use, but I think this is the best. There are infinitely many solutions are all real numbers. A positive number will always be greater than a negative 7. So you don't actually need to split this one up. So the practice problems. I'm going to do these pretty quick. But I will work them out for you. So I'll just go ahead and set them up. I want to find the numbers that have an absolute value of 5. So 5 and negative 5. It's a less than. So these are open circles. When it's a less than, that's an and inequality. So I'm going to shade towards each other. And then the way I describe that is to the right of negative 5 would be greater than negative 5. And to the left of positive 5 would be less than 5. Whatever's on the inside, x plus 1, x plus 1. To solve, you subtract 1. I'll just do them all at the same time. X is greater than negative 6. X is less than positive 4, which you can write as negative 6 is less than x is less than 4. If it's an and inequality, you can do that. So I'll put negative 6, I'll put 4, and I'll just basically recreate this graph. Open circle, shade the middle. Last one I'm going to do has a few steps, so it's got kind of combine everything. Whoa. We need to first, in this problem, isolate the absolute value. So you need to undo addition first, like any other equation you've ever solved. Undo addition first. 27 minus 2 is 25. We're still not by itself. You have 5 times, so you need to undo division, subtract 5. Now we have the absolute value is greater than positive 5. So if you think about what that looks like, the numbers that have an absolute value of 5 are negative 5 and positive 5. Since it's a greater than and not a greater than or equal to, they're open circles. And when it's a greater than, that's an or, so these are going to shade away, because the numbers that have an absolute value of 5 are going away from 5 and negative 5. Now we need to describe it. So to describe it, we say the numbers that are less than negative 5 to the left of negative 5 or to the right of positive 5. And then you just take the 3x minus 1, and that goes for both these equations. So when you add 1, you get negative 4, divide by 3. X is less than negative 4/3, or you can say negative 1.3 repeating if you want. Add 1, 3x is greater than 6. So x is greater than 2. So the way we say that is we draw the same number line. We're going to put negative 4/3 on the number line. We're going to put positive 2 on the number line. They're open circles. And since this is an or, we're shading away. It can't be both. It either is smaller than negative 4/3 or it's bigger than 2. And that's it for absolute value inequalities. If you can do that, you can do a lot of different things. So good luck on your test.